Hi students. So in today's session we'll discuss about oscilloscope. So this is your syllabus. So in this syllabus we're going to discuss an oscilloscope. So what is oscilloscope? Before moving to the lecture, let us put a question on the oscilloscope. Have you ever seen an oscilloscope? Yes. You might have seen an oscilloscope in your lab. Most probably an EC student, a first year students, you might have seen an oscilloscope in your EDC lab. Okay, so this is what your oscilloscope pictures. So this is your oscilloscope. I think you might have seen a similar instrument in your lab, and inside that you'll have a CRT like this. We call this a CRT, and this is your front panel of CRO. Yes, let us now see your cathode oscilloscope. It is shortly called as CRO. Okay, a CRO is probably the most versatile tool in the development of electronic circuits and systems. Okay, so application of CROs. It is mainly used in laboratories for research and design, and you might have seen this. It is used in TV receivers. Okay, in a not olden days. So before the invention of LED, LCD, and plasma TV, we have a TV with CRT monitors. So that is an application of CRO. Next, this is the block diagram of cathode ray oscilloscope, and you might have seen some blocks. We'll discuss this block one by one in the next slide. Yes. So the first part of the cathode ray oscilloscope is CRT. Okay, this part we call as CRT, cathode ray tube. Okay, then vertical amplifier. Okay, so this is your vertical amplifier, and the next one is delay line. These two block is belongs to vertical sections. Next, time base, time base, horizontal amplifier, then trigger circuit, and this is responsible for horizontal deflections. Then at last we have a power supply. Okay, we have two types of power supply here: high voltage supply and low voltage supply. Okay, let us deal one by one now. So the first part is cathode ray tube. It is one of the important part of CRO. So CRT, we call this cathode ray tube as CRT. Okay, this is one of the diagram. Okay, and this is another diagram. So you can take any one diagram for an explanation. Say for example, this CRT consists of heater, cathode arrangements, where these two are responsible for producing an electron gun, electrons. Okay, so once the electron is emitted from this cathode, it passes the grid. Okay, this is your control grid. Okay, and from here it moves to the different accelerating anodes. Okay, then it enters into the deflection plates. You have two deflection plates, vertical plate and horizontal plate, and then the electron will hit the screen, and this screen is being coated by phosphorus material. Okay, so your CRT is like this. This is the cathode ray tube which emits electron that strikes the phosphorus screen internally to provide a visual display of a signal, right? Next part is vertical amplifier. So before going the vertical amplifier, I want to say about two deflection plates. You have two plates. One is vertical deflection plate, another one is horizontal deflection plates. See, if you take any picture, we can segregate into x and y axis. The image can be splitted into x and y axis. Okay, so here also the vertical deflection plates is given over here, and horizontal deflection plates will be given over the x axis. So what is vertical amplifier? Okay, so through this block also you can understand. Okay, so vertical amplifier, this is a wide band amplifier used to amplify signals in the vertical section. So nothing but the input that we want to measure an unknown signal will be fed to the vertical amplifier. Why it is amplified here? Almost the signal that has been given to the CRO is an almost a dead signal. Okay, to improve the quality of the signal, it has been amplified. Okay, then the next part is delay line. The name says delay line, it delays the signal for some times in the vertical section. Now an horizontal section. Okay, so in this section we'll discuss first time base. What this time base generator does. Okay, the name says generator. It used to generate a sawtooth voltage required to deflect the beam in the horizontal section. Next part is horizontal amplifier. Okay, so this is used to amplify the sawtooth voltage before it is applied to the deflection plates, horizontal deflection plates. Now the last one, trigger circuit. Your trigger circuit, this is used to convert the incoming signals into a trigger pulses so that the input signal and the sweep frequency can be synchronized. Okay, the last one is your power supply. Usually the cathode ray oscilloscopes comes with two power supply, one with the high voltages and other one is low voltages. Okay, the high voltage will be in the order of 1000 to 1500 volt and it is applied to your CRT section, and the low voltage of the order 300 to 400 volt and are applied to the other parts of the CROs. Okay, now let us see the working of CRO, how a CRO works. Okay, so this is your, on the right hand side you may see CRT, present CRT is been given. Okay, so when the electron is injected, through the electron gun, it passes through this grid. We call this as control grid. Okay, the control grid controls the intensity of the electron in the vacuum tube. Okay, if the control grid has negative potential, then it allows only few electrons to pass through it. Thus, the dim spot is produced on the lighting screen. Okay, if the negative potential on the control grid is low, then the bright spot is produced. Hence, the intensity of the light depends on the negative potential applied on the control grid. The last, after moving to the control grid, the electron beam passes through the focusing and accelerating anodes. This accelerating anodes are at high positive potential, hence they converge the beam at a point on the screen. Then after the electron is moving from the accelerating anode, the beam comes under the effect of the deflection plates. Okay, the electron beam will now move to your deflection plates. When the deflecting plate is at zero potential, the beam produces a spot at the center like this. If the voltage is applied to the vertical deflecting plate, then electron beam focus at the upward, and when the voltage is applied horizontally, the spot of the light will be deflected horizontally. This is your CRO works. And you have a special purpose of oscilloscopes. So dual beam oscilloscope. So far whatever we discussed is a single beam oscilloscope. Only one signal can be seen. Now you have a dual beam. Two electron gulls will be there. Then dual trace CRO, you can measure two voltages. Digital storage oscilloscope. Now you can record the waveforms using this type of storage oscilloscopes. So you can see a dual beam CRO. This is a block diagram of dual beam CRO. Now you can see the vertical section now as two things, two blocks. Okay, so channel A, channel B. The other parts are very similar. Similarly, dual trace oscilloscope. This is also almost equal to the dual beam oscilloscope. So here also two channels. Then digital storage oscilloscope. This is the block diagram for digital storage oscilloscope, where you have more digital circuits. Okay, and the data can be stored here. Okay, I hope you understand storage oscilloscopes, CRO, cathode ray oscilloscopes. If you have any queries, you can comment on the buttons. Thank you one and all. Thank you one and all.